Now we get into actual refactoring. We had this kind of pseudocode for returning book. And in the middle of this, we had compute finds. This involved a lot of code, and it kind of stood apart from the rest of the code. This increased the size of the code, and it added to the complexity. So if you look at this piece of code, this can be kind of extracted, put as a separate method. So that is our first refactoring rule, extract method. We have a code fragment that does one thing, that is computing fine. So all that code can be grouped together, and we can put that into a separate method, give it a name, and explain the purpose of the method. When does that happen? Well, if you were to write the Java code for this, we would be tempted to put a comment around here saying, now let's compute the fine. That means maybe this is to be put as a separate method. When you find yourself, when you find that you are needing to add some comments to explain what you are doing, it is probably an indication that you need to carefully see whether that code belongs to that method. If you don't put in front of this code, let's now compute the fine, because this looks very different from the other kind of stuff like searching for a book and returning the book. This is very different. This is all financial stuff. So you need to put this apart. That is our first rule, extract method. If you have a code fragment that can be grouped together, that does one thing, and you think it doesn't quite belong in its functionality, it doesn't make things cohesive, you need to put that into a separate method, give it a name that explains the purpose of the method. So what we do is we create a method called compute fine, and when we do that, we have this kind of code. Double fine equals 0. We need the book object to get the due date and the acquisition date, etc. So this piece of code requires the book object. So if you make this a separate method, compute fine, we need the book object passed as a parameter. Now you can use the book object to get the due date, and we pretty much have the same code that we had before. Actually, this should be 0.25, and this should be 0.15 plus. And let me fix the other one too here. And I will put this new version out. Not that those things matter too much, but nonetheless. Okay, so this is essentially the same code that we had before, but we simply put everything into this method called compute fine, which explains the purpose of this code. And since we need the book object to get the relevant information, we put as a parameter. The variable fine, which was in the other piece of code, is now a local variable, and we return that. So the return type is double. Now, look, if you look at this method, this is in library, because we are the return book method is in library, and the compute fine method was just extracted from return book and put as another method in library. But if you look at this piece of code, almost all the data that you need is from book. Look at this, book.getDueDate. We need something from the book object. And we are playing with the due date here. We are getting the acquisition date, book.getAcquisition date, and we are playing with those two things here. Everything else is basically stiff stuff that we can get from anywhere, like these constants and stuff like that. Book.hasHold. This local variable can be doesn't matter. So all the relevant data are found in the book object. So it suggests that we shouldn't be putting this method in the library class, because if you put this in the library class, you're importing all the information from the book class. So this is not a good idea. We should move this method to the book class. That is the second refactoring rule that we are learning. Move method. If we have a method that is using more features of another class, that is, we are having a method called the compute find here that is using fields of the book class than the class on which it is defined or in which it is defined, that is library in this case. Then the method needs to be moved to the class whose feature it is using the most. In this case, it is undoubtedly the book class. So we move the compute find to the book class and then write it like this, compute find, and we don't need the book object to be passed because this is the book object. I mean, that keyword this is the book object in question. So we don't have to worry about getting the acquisition date. They are all fields. That is a field. Due date is a field. So we move the days elapsed and all that stuff year apart, everything to the book class. We don't have to write book.hasHold. We just write hasHold. Now, this might actually prompt a thought, why not refactor some other methods? So if you try to refactor something like remove books, okay, which has this sequence, which is somewhat reminiscent of return books, get the book object and see if it can be removed. And if it is not removable, return an error code, otherwise remove it from the catalog. If you try that, as you can see here, if you try to have a method like check removability, that is right here, right? Check if the book is, you have to check that, right? The question is, can you extract that method? If you extract it, it doesn't really serve any useful purpose. You will have to have all those things, all those return codes right in the method. There are too many return points. This is just a useless attempt.